Before we get going into this, I should point out the cat is currently sat on my lap. So if you do see something with 4 paws and a tail walking past, it's a cat and not a rat wearing a hat sat on a mat. So here we go. Let's find that equation of that regression line or that line of best fit. Now we should all know by now that the way you define a straight line is by its gradient and its intercept. And we're not going to do anything different this time in terms of our line of best fit. The notation we tend to use at this stage is we tend to call the gradient B and the y-intercept we tend to give it the letter A. And when you come to look for getting your calculator to do this, which I'll do an example of later on, you're looking for the letters A and the letters B somewhere on the keypad or somewhere inside the calculator's settings in order to calculate it for you. So it's very, very straightforward. If you've done some work on how to find correlation coefficients, finding the gradient and the equation of line of best fit is really, really easy. Step 1, how do you find the gradient? You literally calculate SXY and SXX, and the gradient for your equation of line of best fit is SXY divided by SXX. It is that easy. Let's just remind ourselves how we find SXY and SXX. SXY is the sum of x times y's, taking away the sum of x times the sum of y divided by n. And SXX is the sum of all your x values squared, taken away the sum of the x values squared divided by n. What does that mean? Well, let's look at an example. That's probably the easiest way to show this. Let's come back to my example involving caterpillars and cabbages that have been eaten by those caterpillars, which is an example I've used before. Here's my pairs of values. When there were 4 caterpillars one summer, they ate 5 cabbages, and so on and so on. I find my sum of x values, my sum of y values. I then take all my x values and square them and add them up, and hence that becomes my sum of x squareds. I do the same for the y values, square them, then add them up. I then also take each pair of x and y's and multiply them to get my xy values, and then I add them up to get that. And then to turn that into SXY and SXX, I substitute them into the formula just as we've done before, and from this data I found before that SXY was 5 and SXX was 8.75. So this is now going to make it really easy to calculate the gradient for this set of data. The gradient is going to be S of xy divided by S of xx, and we found that S of xy is 5 and S of xx is 8.75. And if I had a calculator with me, I'd put that in, and that will give me the gradient of my line of best fit. It really is that simple. And I've just worked that out on the calculator on my computer, because I don't have a calculator next to me at this moment. And that, ladies and gents, is the gradient of the equation of the line of best fit. Now the next thing we're going to need to do is to find the intercept. Now we found the gradient, the next step is to find the intercept. But before we can actually do that straight away, we need to first of all find x bar and y bar, the mean x value and the mean y value. So to do that, let's go back again to my set of data, and let's remind ourselves how we find the mean. To find the mean of x, I'm going to take the total of x and divide it by the number of results of x I had, and do the same for y. So x bar, in this case, is going to be the sum of x divided by n, which is 15, divided by 4 pairs of values, which is 7.5, which is 3.75. Y bar is going to be the total of my y values divided by the number of results, and in that case it's 16 over 4, which is 4. So I've now got x bar and y bar. Why is that so important? Well, step 3 to find the intercept of the line requires us to have a pair of values that we can apply the gradient to. Let's think this through. Y equals bx plus a, and we're trying to find what a is. Well, we now know what b is. We've now found the gradient. If we had a pair of x and y, we could substitute it into here and find what a is. Well, that is what our x bar and our y bar are going to be used for. So let's substitute in what we now know. We've just calculated that y bar is 4 and x bar is 3.75. We need to just find and remind ourselves what our gradient was. So let's just go back a few pages. And the gradient we came up with was 0.5714. So now all we need to do is do 0.5714 times 3.75, take that over to the other side, and that should give us A. And having done a quick calculation on my computer, I've worked out that that comes to 2.143. So take it over this side. 4 take away 2.143 will give me my value for A, which will be 1.857. So my intercept is 1.857. So let's sum everything up together. We said the equation of a line is y equals the gradient times x plus the intercept. And we now know that our intercept is 1.857, assuming I've not mucked up that calculation, and the gradient we found was 0.5714. Ta-da! We now have our equation of line of best fit, or our regression line. And now that we've got this, if I know a value of x, I can substitute it in here, times by 0.5714, add 1.875, and that will give me y, and vice versa. But let's remind ourselves, we don't get any credit as statisticians unless we interpret our findings. So what does this mean in real life terms? Let's go back to the data we had. Remember, x was the number of caterpillars I found on my cabbage patch each year, and y was the number of cabbages that they got eaten. In other words, for every caterpillar that gets added to this cabbage patch, an extra 0.5714, an extra 0.6 of a cabbage is going to get eaten. If I had no cabbages, here's an interesting one. If I had no caterpillars on this cabbage patch, I could still expect to lose 1.8 or 2 cabbages, presumably to natural causes such as heart attack or maybe emigration. So ladies and gentlemen, that is it. That is how we find the equation of the regression line or the equation of the line of best fit. The next thing I'm going to do is do a worked example of an exam question, and then hopefully you've got enough to be getting on with.